For years, developers have used waves to create realistic water effects, rolling landscapes, and more. These waves, repeating themselves endlessly, trick our eyes and make us believe in worlds that don't really exist. But today, we're breaking the mold. We're diving into the world of waves in isometric projection and try to build this cool isometric wave visualizer. In this video, I'll briefly showcase the math behind it without diving deep into explanation. If you want detailed explanation, make sure to watch this video. Here is the two-dimensional grid. In order to transform it into isometric one, we need to apply some transformation. Let A and B represent the height and width of each cell of grid. First of all, we rotate this grid by 45 degrees and squash it in half. First vector moves 1 unit and 0.5 unit in x and y direction, while second vector moves -1 unit and 0.5 unit in x and y direction. So mathematically, this whole transformation can be written as 2D vectors for both directions. If we multiply any x and y coordinate from 2D grid and sum them, we get new isometric coordinates. Now we incorporate height and width of our tile by simply multiplying width with horizontal component and height to vertical component. There is one more problem. Grid is squashed by half unit, so we need to divide width and height of our tile by 2. At this point, we are done with all the mathematical details. Let's begin implementation. I implement this whole program in Raylib library, available for both Python and C language. Python installation is straightforward. For setting up Raylib in C language, I'll recommend you to watch these videos. We start our implementation by making a window in Raylib. Here I make a function that is used to toggle full screen mode whenever user presses the space key. Now let's import the sprite and render a grid of sprites in normal coordinate system. Let's recall the transformation. Here we are doing the same transformation in order to get isometric grid. Finally, we have successfully achieved isometric transformation. Let's quickly offset the grid. Here I am using this function. Feel free to do experiment and try out new functions. it looks amazing, but what about adding mouse interaction? I'm sure you can achieve such results. If you think this video has provided any value to your existing knowledge, I invite you to subscribe to this channel and give this video a thumbs up. Your support not only helps the channel grow, but also ensures you never miss out on more fascinating content.